Hi everyone. Today I will present a Kafka-based order processing system that demonstrates enterprise-level message streaming using Apache Kafka with Avro serialization. This project showcases how to build a fault-tolerant, scalable runtime data processing pipeline that can handle all the streaming, process them accurately, and provide real-time analytics. These are the technologies that were used in this project. So let me explain how a message flow through this system from start to finish. First, the client send an order as JSON via REST API. Here they might send order details like order ID, product name, and price. Second, the order controller receive this request and validate the input, checking the all required fields are presented and validate. Once validated, it forward the order to the producer service. That the producer service take that JSON data and serialize it into our binary format. This makes the message much smaller and more efficient. The producer then publish this Avro message to our Kafka cluster. The consumer service read the message from Kafka, deserialize it back from our format into our order object, and validate the business rules, making sure the price is positive, the product name isn't empty, and so on. Now, at this point, the flow split into two possible paths. First, the success path. If processing succeeded, the consumer update our price aggregation service with the new price, calculating the running average, minimum and maximum values in real time. Then it acknowledges the message to Kafka, making it as successfully proceed. Second, failure path. If something goes wrong during processing, maybe a validation error or temporary system issue, the consumer send the message to our retry topic. The system will automatically retry process up to three times with a 2-second delay between each item. If after three retry attempt the message still failed, we consider it a permanent failure. At this point, the message is moved to dead letter queue where it log for manual investigation. This present bait message from blocking our pipeline while ensuring we do not lose any data. And throughout this entire process, the schema registry acts as a central authority, ensuring that the producer and consumer always using compatible version of the Aura schema, and this allow us to evolve our data structure over time without breaking the system. So these are the Kafka topics were created when running our system. So let's see code structure and key component. Okay, first let's look at the Aura schema. This defines the structure of order message. So here the namespace defines the Java package where the class will be generated. So in the form.xml file, we define the dependencies and plugins. Here the Avro Maven plugins, we configure the source directory and the output directory. When we build this project, this order class automatically generated. Uh, so let's see one every let's see the services in the price. producer service. The producer service handle the serialization and publish to Kafka. In order consumer service, this the most complex component. It handles message consumption, validation, retry logic, and DLQ routings. And the price aggregation service. So this service calculate real-time statistic using thread safe atomic operations. Finally, in the DLQ consumer service, the DLQ consumer monitors permanently failed messages. So now in the order controller, I have defined all the API endpoints here. Now let's see everything in action. I will demonstrate the complete workflow with different test cases. So first, I need to start the Kafka instruction using Docker Compose. I have defined the Docker Compose file. In here, I use I use the necessary Docker images, Kafka, Zookeeper, and the schema registry. And for my easiness, I have written the Docker code here. So first we need to start the Docker Compose. So the Docker container, the container is created and running. Let's check the running container. So let's check each test cases. So I have already defined uh, the API documentation. So first start with the health. First I need to run the project initially so that I start this Spring Boot. When I start this project, all the topics are automatically generated. And let's see. So you can see the status is up. The So first I will send a single order. So this the message is so the successfully send the topic. I have sent a product name is a laptop, order ID is a order 001, and price is 1,299 $0.99. So this produce a topic and send it to the Kafka. So here you can see the order 001 successfully processed, and here we can see price aggregation, the minimum price and maximum price, and running average. Next, we will see the batch of order. So here I have defined the batch of order here. Just run it. So the batch process completed. The the success count is 5. I have defined 5 orders, so there's no fault count here, and we can see it through here also. So you can see the order 002 topics in order topics. Partition is 0 and offset is 1. That order 3 partition partition 0 and offset 2, and order 4 partition 0 offset is 3, and order 5 in partition 0 offset 4, and in the order 2 partition is 0 and offset is 1. Now let's see schema registry. Initially this schema registry is empty. When we start the project, it will adapt here. The schema registry says that order topic values. There's a schema study registry name is order topic value. So now we see the aggregation statistics. So here you can see there is a total 6 orders, and average is 420, and minimum price, maximum price, and total sum. Notice that the running average is calculated in the real time as each message is consumed. So here no database query needed because of schema registry. Now, let's see how the message is stored in the Kafka, so that so that so here I use a Docker command to check the consumer console topics. So here you can see the orders, but this is the our this is the in Avro format, can enable to read the all messages because of our schema. So so now we'll see the deserialized message. Here you can see the deserialized message from the Kafka order topics. So now let's check the retry. Is there any retry topic or DLQ topics? So yeah, so here we can see that there is no retry topics. So here also we can see that there's no DLQ topics. So now let's see what are the Kafka topics have been created. To do that, first we need to enter the Kafka container, and then we need to run this command. So here we can see that there's a order DLT topics, order retry topics, and order topics, and also the consumer offset and schemas are automatically generated. Now, let's check the consumer group status to see the partition assignment and legs. So, so here we can see that the groups, topics, and the partition, current offset, leg, log and offset legs, consumer ID, all the details. So I have given some uh, explanation here. So first we have so here we can see two partitions. So so it allows the parallel processing. We could potentially run two consumer instances simultaneously with each one message from different partition. This is how Kafka achieves horizontal scalability. We can increase throughput simply by adding more partition and more consumer instance. So second, look at the leg column. So here uh, the leg column it shows 0 for all partition. This is so the leg represent the number of messages that have been written to Kafka but not yet consumed. A leg of 0 means our consumer has successfully processed all messages and there's no backlogs. In production system, we would want to monitor this metric closely. If legs start increasing, it means your consumer cannot keep with the incoming message rate, and we might need to scale up. So next, we need to note the current offset equals log n offset for current offset and log n offset. The current offset is the position of the last message our consumer has processed and acknowledged. The log of n offset is the position of the newest message in the partition. So when these two numbers are equal, it confirms that our consumer is uh, completely catch up. There's no unprocessed message waiting in the queue. So these are the main thing we need to consider in here. Now let's see our schema registry. Uh, so here, we can see the schema registries, field names, types. The name order type is string, and likewise there's a three fields here. The schema registry under the subject order topic value. This enables schema evaluation. We could add a new field without breaking existing consumer. That's the biggest advantage in this system. So now let's see send bulk number of requests. So I have created the test case. We run with 100 test cases. So we can see the duration within 2.446 seconds. It take to take the 100 number of requests in a particular time. Next, we will uh, check with an invalid order. So here I created the price as a negative value. So let's check it. So the message says the price must be greater than 0. The status is error. So this message does not pass to the Kafka topic. And finally, so we will check any failed topics are there. It's no failed order topics. Every topic has successfully consumed.